All right, for B21, guys, quiet, please. That's just more of a reflection question than anything else. So however you answer is up to you. But they say that, say, for example, you have y equals 20 times 3 to the x power. Can you complete a table? Of course you can. If you make a table for that, it's not that hard. Just plug in different values of x, see what you get for y. Usually reasonable values of like 0, 1, and -1. Like if I plug in 0, I should get 20. Plug in 1, I should get 60. Plug in -1, if you use a calculator for that, do 20 times 3 to -1 power, which I haven't taught you guys how to deal with negative exponents. A negative exponent just flips the base. When I say flips the base, it actually makes it a fraction as 1/3, which makes sense because you're multiplying by 3 as x increases by 1. So anyway, you can graph it. You can come up with a word problem. A lot of different situations you could do. So however you answer that question, it's kind of up to you. Now for 22, that's an actual math question. Make a reasonable sketch on your paper. So it says, can you sketch it without making a table? You can. What's the initial value? We talked about this. What number in that equation represents the initial value? Which number? The 7 or the 2? The 7, totally, right. The first number you see is going to be the initial value. So I'm going to put 7 on the y-axis. And if you think it's a doubling, right? What's double 7? You squaring. 14, right? Because if I plug 1, I get 14. So yeah, you totally can. And you know the graph generally looks like this. So you don't necessarily need to make a table. You just look at what's in the equation, right? 7 is the initial value. 2 is a growth factor. Start with 7 and double it. If you want to double again, you get 28, 56, 112, 224, and so forth. For 23, if you want to finish a table, that's not hard. You have to find the ratio. What was the ratio between these two? Okay, so multiply by 3.2. If I get a calculator, not that hard, right? 18.432 times 3.2 is 58.9824. 188, whatever. Now here, this is a little tricky. How many times do I have to multiply by the ratio to get from the first point to the third point? How many times do I have to apply that multiplier? Twice, right? So what you could do is you could say this: 245 over 5 equals b squared. Because you got to multiply by b twice to get from 0,5 to 2,245. Whereas for a, every jump was 3.2 when I found the ratio. So if I do that, I should get 49 equals b squared. So b is 7. So you got to jump by 7 every time. Or multiply by 7, that's what I meant to say. So you multiply by 7 every time, and you should... You are correct. Thank you. My bad. Did I do the rest right? Yeah. 1715. And times 7 again. Yeah, 12,005. So, and again, I'll publish the answers when I get a moment, when I get a chance to do that. Next up, 24. Brianna's working on her homework. Her assignment's complete up to come up 4 representations. She chooses that equation. Okay. So a table, obviously, right? Let's plug in 0, you should get 1200. Plug in 1, you should get 600. Plug in 2, you should get 300. Now, what does x represent? Looks like x represents actually, I don't know what x represents. Hold on. What is this going on here? Maybe it could be... I'm gonna totally BS this. Maybe it could be the number of vocab, or sorry, maybe the number of words she has to write for an essay. And so after each hour, only half, or after each hour, she has half as many words left to write. Does that make sense? I don't know. Just came with the situation. Go, Alexandra. Okay, sure.
I just like explained the graph. Is that okay?
That's fine. I think they want a context, but that's okay if you didn't come because it's hard to do because I was kind of at a loss. I even said I totally just BS this. I just something that makes sense. But let's say your teacher said, "Oh, you got to write 1,200 word essay by tomorrow," and you figure, "Oh crap, 1,200 words, that's a lot, right?" But after every hour, you get down by like puts it down to 600, right? Then after another hour, you get down to 300. You get it down to 150 and so forth. So you could say that it could be that perhaps. And the graph looks like this. It's just gonna be you never will, right? Exactly. The last word, you can't figure out the last word to have finished your essay, right? But yeah, and the graph will look like that. For 25, that's just graphing parabolas. That's just old stuff. Um, so next is 1, y is 1. That's easy. But if you graph 2x squared, it's going to be steeper, right? So it kind of look like this, perhaps. Or 1/2 x squared, it's going to be lower. No, you should draw the whole thing, but I just felt like doing that for now, just to accentuate how different those are. And just so you know, the black is y equals x squared. The dark green is 1/2 x squared. And the blue, dark blue, is 2x squared. We're not there yet. We are going to talk about um, vertical stretches of graphs when the time's right. Probably in October, November, we'll do that. So how are they similar? Same vertex, I'd say. They both open up. Differences, the width. I think that's pretty obvious, right? The width changes based upon what the number in front of x squared. So if you said something like that would be valid. And lastly, 26. I won't go over the extra for experts. I'll put the solution key up and you can just talk to me later about it. Okay, this is good because today's homework quiz is very similar to this, and also like a problem like that with the marbles from last week. So y equals mx plus b, right? This is the guiding principle here. Y equals mx plus b. So what does b represent, guys, in a linear function? What is b? B is y-intercept. And what's m? What's m? The slope. Good. Right. So m's the rate, and b is what you start with, right? You start with b. So Morgan starts at $615 and gets $25 every week. So Morgan's easy. 25x plus 615. How about Kendall? How do we make her equation? Yeah, she's spending money. Context, right? She's spending money, not saving. Plus 975. Ultimately, they have to meet up, right? Because one person's money is dwindling, another person's money is growing. When do they meet up? How do I find Adelaide? Good. Okay. So how do I find when they meet up? What do I do? So I'm equal. That's it. Thank you, John. Yeah, that's it. So I'm gonna have you guys do something kind of like that in the homework quiz. It's the one I give you guys is tougher than this one, but tough is good. I gotta stretch you guys, right? Because I feel like, if I want to get you guys ready for our next test, I gotta stretch you guys a little bit. But hopefully putting your heads together will help. So solve it. Should be pretty easy. 40x equals 360. X is 9. Yeah, so 9 weeks. They have the same money. So okay, we're cool. We're going that? Okay. Let me show you the homework quiz right now, just so you guys could think about it a little bit. But I'll have you work on it when we get there. So, as you guys know, juniors are doing PSAT next month, right? Sophomores might do it as well. I don't know. So, this is on your radar. It's coming up pretty soon. Or just juniors in general doing SAT sometime later in the year, or ACT. So this is from a SAT prep book. So you have two garages. They both charge an hourly rate and a fixed rate. The fixed rate's like your y-intercept. The hourly rate's like your slope. And they give you some scenarios. So you have to make equations from those scenarios. And then you have to solve the question at the end. I'm gonna just hide it now. I'm not gonna. I'm gonna hand it to you guys in a moment after we finish the lesson today. But I want to just show you what to expect. It's something like that. So you can start thinking about that. Anyway, let's go through the notes. You guys should have the notes. I gave the notes for the whole week. If you lost it, I have extra copies. But you should have the notes packet. I gave it to you guys on Wednesday, I think. On Wednesday, I gave you guys a notes packet, I think, or Friday. No, so you're right. It wasn't enough on Wednesday. On Friday, I gave I had extras though. You were here. Okay. If you don't, I have extras. So. That one did we? John. You need it, John? Yeah. Okay. 12 feet one. Yeah. Oh, yeah. Sorry, Alice. You did say that. There we go. You know what? Anyone else? No. All right. So let's go to B3. Very short, only a couple pages. This is very formula intensive, and I think. Oh wait. You got okay. I think we do provide these formulas. I have to double check. Maybe we do, maybe we don't. But we're gonna be using quite a bit of formulas today. All right. And these are word problems, all dealing with money. So it's finance. Okay. So let's talk about saving for college, okay? So some of your parents or somebody in your family, maybe they save money for college. I don't know. So say you got $1,000 to invest. You have two investment options. You can invest in a bond. A bond pays 8% civil interest. If you need one? No, okay. Or you can put it in a credit union account or a bank, and it pays compounding interest. Compounding interest means in certain intervals, interest is added onto the account. So, like for example, if you have $1,000, great, you get 8%. After another year, you get another 8%, another 8%, and so forth. Whereas simple interest is a little different. You'll see how that works in a moment. So, which option should you choose? Will it make a difference? Let's find out. So, simple interest is, as the name is implied, is simply a linear function. Just want to tell you right now, it's a linear function. Compounding interest, we'll get there in a few minutes, is an exponential function, but simple interest is simply, no pun intended, a linear function, okay? So here's how it works. The amount of money you have equals the principal Let me explain what all these things are. I know it looks a little confusing at first. Bear with me. It looks a little confusing, but bear with me here. P, we put a text box. P is going to be the principal, which is your initial deposit. A is going to be the amount of money after T years. T is going to be the number of years. And R is going to be the interest rate expressed as a decimal. The T should be pretty intuitive. That's time, right? R should be intuitive, rate. A should be pretty intuitive, amount. Actually, all these are intuitive. P may not so much. P stands for principal, which is a finance term. Some people may not know what that means, but principal in finance just means your initial deposit, how much money you started with. So how much money are we starting with? $1,000. And what is our interest rate? 8%, great. And then time is up to us, how long we want to invest the money. And we want to see how much money we have after a certain period of time, right? So that's all that you're doing here is you're simply keep saying the word simply for simple interest. It's just a linear function. So if you invest in bonds, your $1,000 of gross shown in the table to the right. So here's how I'm gonna actually work this out. My principal is $1,000. 1 plus, what's my rate again? It has 8% expressed as a decimal. 0.08. Yeah, good. Now, let's distribute if I distribute the 1,000 inside, what do I get? I get 1,000 plus what? Yeah, whatever 1,000 times 0.08 is, which is 80, by the way. Okay. Do you see how this is very similar to y equals mx plus b? This is the connection I need you guys to make. Okay, first off, I gave you a wacky formula. I told you all those things. Right? You know, R is great. P's high. P's principal. Didn't the cheese person? Big cheese man?
No, don't just bring up the-
I was off by one, by the way. The Minnesota score. I was off by
A lot.
a lot. Yeah, 14 points. I know. That fourth down, and then the Jefferson touchdown just about. Sorry, go ahead. Oh, thank you.
Yeah, she just-
Okay, no problem. Okay, so anyway, get back to this. I'm sorry, I guess I digress about football.
Does this equation apply to just linear functions or does it apply to exponential?
Just this is just linear,
Okay.
just simple interest. We have a new one for the next one. So if you think about this wacky formula, if you distribute, so if you figure out P is 1,000, R is 0.08, T we don't know. T is independent, by the way. If you get to choose how long you want to invest the money, like say for example, like I have a son who's 7, so say I want to start a college fund firm. Okay, great. I start now and do it for the next 11 years. Moves on to college for 10 years. Okay, great now. So yeah, so right, that's I get to choose that, right? But A is dependent. A depends on time, right? Now when it's 1,000, look at it. 1,000 plus 80t. Which of these two numbers is my slope? Okay, I stop about football. I know Saints did well. I know Cowboys suck. 80, right? I know I love football. 80. 80 is a slope, right? What's my y-intercept here? 1,000. Good. So that's very similar to a linear function, right? So to fill out the table, I'm just adding 80 every time, right? That's all you're doing. That's why it's called simple interest. You're simply adding $80. That's it. It's not very creative. It's just a simple formula. Good.
Does it need to be written as 1,000 plus 82?
No.
Can it be 80?
Whatever you want. Doesn't matter. I don't know why I did it that way, but yeah.
Because usually slope is.
Yeah, no, I mean, yeah, usually we like to write the variable first and then number second. Whatever you're comfortable with, it's fine for me. So yeah, that's pretty simple. And by what percent will your balance have increased at the 4th year? Well, to answer part B, so again, part A just means you get $80 per year. Well, hold on, let me understand this question better. By what percent would your balance have increased? Yeah, oh, so I see what you're doing. So John, what you're doing is you're subtracting the 4th year by the initial amount. Okay, good. Yeah, we'll see that. Yeah, whenever you look at percent change, I'm not sure if you guys know this. And by the way, this is actually a great SAT formula to use. This is done often on the SAT. Percent change is new minus old divided by old. So if this is the new value, what was the old value from 4 years ago? So you want to see how your money has changed over 4 years, right? Like people love doing this. Like, hey, I bought a house 10 years ago. How much, did I make off my house? If I bought for $1 million, now it's worth $2 million. I made 100% or whatever, right? So it's kind of the same thing. You just subtract the new and old, but divide by the old to compare. It should be 32%. Okay, so all right, not bad. It's pretty good growth over that time frame. Might be a little bit better with the next scenario. All right, so let's look at compounding interest. So compounding means interest is applied to the account, or percentage is applied at a certain interval. Adelaide, you have a question? Oh, sure. Yeah, let me undo. Here we go. So the percent change is just new minus old. So if let's say you started say you're a freshman in high school, in 4 years you're gonna be in college. I mean, of course, you need more than that one. You need more than $31,020 for college. We know that. But in 4 years, how much money you got? Okay, I got 1,320. Great. And by the way, there are more complex formulas that we should look at. If we get there, that'd be cool. I don't know if we'll get maybe pre-calculus is a good time to do that. But technically, what you should be doing is you should be putting money every month. And interest rates vary as time passes. The formulas get way more complex. So we're just looking at a very basic situation. Okay, now compounding interest. Here's how this works. It's a little tricky. The formula looks like this. A equals P 1 plus R over N raised to the NT power. I know it looks a little confusing at first. Bear with me. You guys will be fine. Let me tell you what each thing represents. A is still the same thing. Amount of money after T years. P is still the same. Principal, which is your initial deposit. T is still the same. Number of years. R is still the same. Your interest rate as a decimal. And N is a number of times the interest is applied, or in the finance world, compounded per year. Applied to your accounts. Okay, that's what all those things represent.
Why, but
Oh my goodness. Thank you. I can't wait to do that. Thank you for catching us. Sorry about that. Sorry for that confusion there. All right. So it's a little different. It's an exponential function, not linear. This is exponential. Meaning you're going to be multiplying, not adding. The previous example, we added the same amount over and over again. Here, we're multiplying by the same number over and over again. In fact, what am I multiplying by? 1.08. Over and over again. That's what I'm doing. I'm multiplying by 1.08 over and over again. And you'll see why in a moment. So you invest $1,000, 8%, compounded once a year. So it means N is 1. Now, by the way, what if I compound the money monthly? Then what would N equal? If the money's being added to your account, if money's being added to your account every month, so how many months in a year? So N would be 12. What if I said your money's compounded quarterly? What would N equal? 4. What if I said compounded daily? 365, unless it's a leap year, like this year. Or yeah, what if I said semi-annually twice? So there's a lot of different ways of looking at it. Or weekly would be 52. Okay. And also the rate we know. So we know all these things. So let me get rid of this. And let's work it out. So A equals 1,000. 1 plus 0.08 divided by 1 raised to the T power. Because N is 1. Or I can get rid of that divided by 1 and just make it that instead. So that's your formula. It's an exponential model. 1,000, 1.08 raised to the T power. So why is there this much money in the second year? Because you're multiplied by 1.08. How's it growing? I mean, I kind of answered part C already. So in order to do this, I can just plug in 4 for T. Or multiply the third year, the amount in the third year by 1.08. Either way, you get the same thing. So I do 1,000 times 1.08 raised to the 4th power. So you get more money. You actually get $40.49 more. So we answer part D. Part C is kind of taken care for us. How's it calculated? That's how it's calculated. How's it growing? Exponential. So which type is better? Definitely compounding is better. And it's 36%. By the way, credit cards, same thing. So that's why credit cards compound interest, because they want to make money off of you. They will not do simple interest. They make way more money. And when they compound monthly, because they want their money every month. So be careful with your credit cards, or try to get low interest. Because does anyone know what interest rates are on credit cards roughly? It's pretty close to 30%. Yeah, it's kind of ridiculous. So be careful with credit cards. All right. Okay, we're almost done. By the way, at the bottom here, you see some of these formulas again. Um, I'll explain what the first one means in a moment, but the second one I already showed you guys, obviously. All right. So let's look at 32. Oh, yeah, smart, good. Oh, sorry. Let me go back. My apologies. I glossed over that. So at the end of the fourth year, we have 1360, right? Well, how much do we start with? $1,000, right? So what you want to do is you want to do 1360 minus 1,000 over 1,000. If you work that out, you should get 360 over 1,000, which is 36%. So it is a better, like, yeah, if someone told you you can make 36% instead of 32%, sign me up for 36%, right? Totally. By the way, let's talk about gosh, I wish I could do this project with you guys. It'd be so cool. If we get a chance, I'm gonna see if we can squeeze in more finance formulas. But if you buy a house, does anyone know what the interest rates are for a home loan, roughly? I know you guys probably don't know. You ask your parents, but it's right now about 6-7%. 3 years ago, it was about 2 to 3%. Now, when someone borrows money for a house, how much money do you think people are borrowing to buy a house, roughly? Just throw a number out there. Probably maybe more, maybe $1 million, maybe $2 million. Can you imagine paying 6-7% of $2 million as opposed to 2 or 3%? 2 to 3% is better, right? So again, that's why we care about percentages. In this case, you want high percentage because you want to get more money. In case of borrowing money, you want a low percentage, right? So yeah, there's a lot of cool social impact, life skills. I could really go off the rails on this stuff, but let's look at 32. Okay, in this course, we're using continuous functions. So continuous means graphs that have no breaks in them. So continuous, just means graphs with no breaks in them. So nice and smooth. So your money is growing like this, right? It's just nice and smooth like that. So let's say there's a third option for your money. You can invest it quarterly, which means 4 times per year. That means that the 8% is divided into 4 parts over the year. Well, if you think about it, okay. So the bank says, okay, we're going to give you 8%, but instead of like at the end of the year to give you the money, the interest, we're going to apply the interest 4 times a year. So it's 4 times a year. How many? What's the right word? Sorry. After how many months will the interest be applied? Well, how many months in a year? 12. And what's 12 divided by 4? 3, right? Every 3 months you get your money. But you have to split the 8% over those 4 intervals. What's 8% split 4 ways? 2%. So a credit card, by the way, I said credit card uses about 30% interest. They split that over 12 months also. So they don't charge you 30% right at the time, but they split over 12 months. Yeah, go ahead, yeah. So model the equation every 3 months so you can do the same formula again. P 1 plus R over N raised to NT. Or it's going to be this. 1,000 1 plus 0.08 divided by what, guys? 4T. Or you can write like this. 1,000 1.02 raised to the 14th. Let's think about it. In 1 year, how many times is the interest applied to your account if it's done quarterly? In 1 year, how many times is your account updated? 4 times. Good. So you should have a 4 here. And every time you update the account, what percentage is going to apply to it? Not 8%, but 2%. So they're going to apply 2% every 3 months. That's why this equation works the way it does. Now, is it better? Slightly. It's slightly better than the one we just did. So let's plug in 4. 1,000 1.02 4 times 4. What's 4 times 4? Yeah. Because if you think about it, for example, I could do the same thing if I go to my retirement account. So the retirement account I have a Sacred Heart. They do quarterly statements, right? So if I look at the year 2020, 2021, 2022, 2023, how many quarterly statements should I get in that 4-year time frame? So I get 4 in 1 year, but how many I get over 4 years? I would get 16 statements, right? And they show me the percent growth that my retirement account has, right? It's in one fund, whatever it is, right? Of course, the money's compounded differently. I'm not going to get into the complexities into that, but that's what's happening here is that the 2% is applied 16 times over 4 years. And if I work that out, what do I get? We'll see here. It's not going to be that much more. You think it would be a lot more, but it's not because it's a trade-off. Okay, a little bit more. You get about $12 more. What do you do? So you get about $1,000, $1,372.79. So just, an extra $6 more. So there's going to be eventually a moment where you can only compound so much and you just kind of get to a certain amount and it kind of reaches a saturation point, like where there's some limit after a while. But yeah, that's what we're doing there. And then lastly, 33. Then we have plenty of time for you guys to do the group quiz and then homework as well. And homework, I have a new homework packet to give you guys. Okay, you invest $1,000 in a credit union from the same problem. How much you have after 20 years? Okay, compounded yearly. Okay, so we're doing compounding yearly. So N is 1. So using this formula right here. So A equals $1,000. 1 plus 0.08. Raised to the 20th power. Okay, let's see how much that equals. Let's get a calculator here. 1,000, 1.08 raised to the 20th power. Okay, you get quite a bit of money. $4,660.96. Okay. The second part's a little tricky though. The second part's saying, if you want to earn the same amount of money with simple interest, what would interest rate have to be? Remember I showed you the formula for simple interest. Let's change colors for contrast. That formula was this. A equals P. Was that right? So my principal is 1,000. My rate, I do not know. I want a new rate. You don't like your old rate, you want a new rate. You're like, hey, I want, a better rate. I want to make that kind of money, right? How come you guys don't offer this, compounding thing? So give me a higher rate in 20 years. So that's 1,000 times 1 plus 20R. And what we're going to set that equal to? Yep, because you want to get that, you want that same money, right? Like, I want that money. And then you solve for R. So you solve for the new interest rate if you're going simple interest. So like, because you're going to see the interest rate is going to have to be much higher for simple interest in order to get caught up. Because simple interest lags beyond compounding is better. Simple interest lags. So how much higher does the interest have to be for simple interest to catch up to the compound? The compound is at 8%. After 20 years, let's say, for example, your parents open this account for you. I mean, you're gonna need more than $4,000 for college, but say right when you're born and maybe when you're 20, you get this money. I don't know. But the solve for R, I'm gonna divide by 1,000. So 4.66096 equals 1 plus 20R. Subtract by 1. It's a little nasty here. Equals 20R. divide it out. Let's see here. You get 0.183 or 18.3%. No bank's going to ever give you that kind of an interest rate. It's too high. But that's what would have to happen for the simple interest to catch up to the compound interest. You need to have a higher, much higher interest rate for something to get caught up. Now, this other formula here, we're not ready to talk about it yet. I think we'll do that Wednesday. It's kind of compounding, but it's compound when you compound forever. This right here, it's kind of like this. If you shoot the key, the second part of that equation is like this part right here. But I kind of just prefer to show you this. I think it makes more sense. I think that's a little confusing. So, but we have a chance to practice in the homework. So homework will look like this. Homework will be two things. I'll bring it back, but homework will be some CPM problems, which I printed for you guys, like 35 is filling out tables. We talked about that. That's like a linear function. Yeah, here we got something dealing with percent change, a percent increase, and compounding, B37. And then there's a problem here on properties of exponents. We talked about properties of exponents last week. I want you guys reviewing this. So like, you guys should be okay with this. It shouldn't be too bad. If you're stuck, the answer's on the next page. So you can kind of figure out, we could talk about it on Wednesday, but it's another worksheet here. So I'm going to hand this out in just a little bit. So perfect timing. We have more than enough time that I had hoped. We get what time again? Perfect. Yeah. So yeah. So I'll give you guys a group quiz. Again, doing your table groups. Also, and once you're done, bring it up. You do have to turn your own paper though. You do have to turn your own paper with your own name on it, but you can confer with each other. And then also the homework, you'll start to work on that. So, all right. The homework from last week, homework 6.
So it's
The last problem of homework 6. It's like that.
Right.
Yeah, you've done it. Yeah, and you guys can use that homework if you want. You can refer to it. It's multiple choice, but you have to show me work. You got to show me some work. It's later. It's later.
You have to solve that whole instead of saying SAT method.
Whatever you want. You can use SAT method. I think you might need to make an equation. No, yeah. I know you're talking like working backwards. That's might be a little tricky.
What about like everything together?
Was that? Yeah, exactly.
Wait, so,
Yeah, that might
oh
be a
yeah,
little.
wait, we can use Desmos though, right?
But you need to make equations.
We're gonna do it. It's got that.
I have to do it on my own.
Right. Just give you a hint. Let me give you a hint, guys. Let me project. Let X equal the number of hours. Let Y equal the money. Okay. I'm not gonna say much more than that. Talk to each other, work it out. Okay, I'll say one more thing. You need 2 equations. One for Main Street and one for what's the other place called? Second Street, right now. You need 2 equations. So Shaw, to your point, from a strategy standpoint, you still have to do like the algebra, but once you have the equations, then you can use Desmos if you want. Actually, no, Desmos won't help. Never mind. You could use no. Not necessarily. This is from an old SAT. Not necessarily. Calculator is good for calculating the slope. I'd say that.
I'm trying to make a table. Find out what it is. It's 1 hour, and then we have what it increases to be, and we can decide. If it's just straight, and then from there.
So that can be a slope of line or stuff. That's key. You gotta know what the line stuff represents. That's fixed now. That's correct. The hourly rate is giving you a slope. So guys, hourly rate's your slope. The fixed amounts are what your y-intercept. You gotta figure out what those are. Because the slope is a rate. It's a change, right? It's how things change as time passes.
Yeah.
Yeah, because I'm just being so generous. That's a slope. If that helps, guys. I'll give you guys a hint. Yeah.
Well, I think the fixed amount is, we can do,
What's up? This sounds good. This one. Not divided. Sure, yeah, go back, sure, yeah, right, yep. Yeah, you want to do that. You want to.
That was saying that they're getting $150 per hour. Plus fixed amount is $2. Part of there, which is not.
Yeah. It's, that's how much per hour. This is for 2 hours. This is for 2 hours. Large amount, but an hour minute. So it's not. This is a fixed amount, so you have to do, you know, I'm saying hourly rate is not like. This is not, this is. But I thought. But that's, yeah, I was gonna say that. I was like, I don't know if that's not right. No, I think I'm right because it's this. This is a. Hold on. So here's. Okay, so one. So that's one, right, that's the y and z. Okay, and then that's low. Is that hourly rate, it's like money per, amount of money per hour, right? Yeah, so then this is it.
I made a multiple choice so you guys somewhat feel validated with your answer once you get it.
It's the hourly rate is how much money it is for one.
Guys, the 153 represents the fixed amount plus the hourly rate, just so you know. Okay, guys, find the slope first. That's gonna be the first thing you want to do. Find the slope first. We have 2 points. Do a table. That's what Eloise has the right idea, guys. Do a table. So Sophia, what you're doing, you're dividing 153 by 2. The problem is that the 153 represents the fixed rate plus 2 times the hourly rate. Because then you're assuming there's no fixed rate with the way you're approaching it. But you have to assume that. So that's what's your best. You better find the slope first, and then find the charge at 0 hours. Because just by showing up, you gotta pay money.
The amount by
That's right. Good work. Good. Good. All right. Does Nathan? He's okay. Yeah. Good. You got it. Good work.
See.
Oh, can we pass up the homework? Here we go.
All right, so then we can do.
And just so you guys know, homework.
153 plus.
That's fine. Yeah, just put it way after that.
Yeah.
Oh, yeah. $5. So I got
So
It works.
Okay, so
We did it.
next time, that what I didn't like.
So this is words, that's what it's.
Don't give us 2 points, right?
Let me.
Find the equation.
We're gonna speak English again.
Find the slope and what? Yeah.
So before that is the
Linear model.
what you call it.
So give me the story, like, let's say one car goes in 2 hours.
That is the hourly rate.
And then another car goes in 5 hours, they gotta pay $15. So let's find the slope, see what the hourly
We
rate is.
subtract 54 to get rid of this 1 hour, and when it's 1 hour, that's just the hourly. The next one's 0 hours, that's just the fixed parking. And I think that might be it.
Next time.
Make that 100, give it a 0.
Oh, and then adding one.
So what's the other point?
So then we just did one. Could be wrong, I'm very excited.
There, you got it.
It's possible. This could be correct. Possible it could be wrong.
Okay, so basically.
But the idea is then you want this to be the fix.
Good, yeah, keep going, good. And then you make an adjustment for the new garage. Yeah, good, yeah, yeah.
All right, so that's the person. I'll explain in a second. I just want to try the rules out first.
You're getting free SAT, bro. Watch tuition. It's big, thanks.
Do I need anything else? I can.
You good. You guys.
So.
All right, good.
I'm gonna put it up here. We have time. We have time. We're gonna have some good. Sweet. So then we can do.
All of it for next class?
Yeah, but the last 2 pages are solutions.
Oh, okay.
Yeah.
And then if you want, we can plug it in, check the accuracy of that. So we could do like, take 2, for example.
They're dropping the science from ACT next year.
What?
In April, I think, or February, it's gonna be optional because it's science reasoning, like,
Yeah,
then they're making it shorter too.
Yeah, we have that.
Yeah, I think part of it, the College Board had to because they were bleeding money during the pandemic. Because the test was so freaking long. So, and also just, you know, when people couldn't take it as center, like, come on, you guys can't figure out how to put on the computer. It's like,
You're good. Okay.
well, some are bringing it back.
Ten or more.
The UCs won't ever bring it back. I think the UCs are kind of done with it. But the problem is that UCs are also challenging to get into at the same time, so it's.
Yeah, but this one takes less time, right? And then if you want, we can check it later, but I think that's it. Makes me
All right.
excited.
Yeah, good. Yeah, you reason it perfectly. Good, good. Excellent. Good work.
Times 3 is 47. And then
Good,
I
excellent,
going to
good. You guys got it. Nice work.
2, which is D.
Okay, we got about 7 minutes left. You guys want to get started on homework, or if you want to relax for your next class, it's all good too. I get it. So yeah, you got it. Yep, good. Okay, homework is the CPM problems and the exponent stuff. So
That's what I was.